I'll figure out a way to get it to you. Okay. All right. So the chart. Have you been able to pull yours up on? You can just, for these yes and no questions, you can just give me thumbs up or thumbs down. Have you been able to pull it up on your computer yet and see it yet? Okay, that's okay. It'll just, if you kind of keep working on that, it'll make it a little easier. So this, I think we're looking at number 2. And you should be seeing my screen. Just give me a thumbs up if you're seeing my screen all right and everything's working okay. Okay. And again, feel free to talk. You'll just have to unmute, and I will kind of mute at the same time. We'll kind of tag team it. All right. So the first question you said that you missed was find the probability of getting one or fewer girls in a birth. Yeah, and so you have to use the table. You have to click on the little icon to view the table. And so the probability of one or fewer, of course, one or fewer means 1 or 0, right? And so that's just going to be the probability of getting 1 plus the probability of getting 0. And you can get both of those from the table. Probability of getting 1 is 0.011. And the probability of getting 0 is 0.001, so 0.012. That's it. You just look at the table. You find the probability of getting 0, find the probability of getting 1, add them together. Okay? So that was number 2B, I think. 2B. Now, C, if we look at 2C, C says which probability is relevant for determining whether 1 is a significantly lower number of girls in 8 births. Which probability is relevant for determining whether 1 is a significantly low number of girls in 8 births? The result from part A or the result from part B? So the result from part B was the probability of just getting 1. And the result from part B was the probability of getting 1 or fewer. Okay. Yeah, so basically, if you want to figure out whether 1 is a significantly low number of girls, you want to actually figure out whether it's 0 or 1. So we'll just put in there that the answer to that one, and you can see that in your review. The answer to that one should be B. So just a couple things on there. That was all we had on those two. So let's go on to number 3, unless you have other questions on that. I will admit, question C is worded kind of oddly, but really the thing to remember is we do cumulative probabilities. In other words, we do 1 and below when we do answer a question like part C. Okay. Question 3. You missed a little bit on question 3. Okay, this is the WCW one. Using the multiplication rule to find the probability of multiple choice questions, each have 4 possibilities. So there are 4 A, B, C, or D, and of course we get 1 right, 1 wrong, or we get them either right or wrong. Assume that you guess the answers to 3 questions. Use the multiplication rule to find the probability of WCW. All right. So you got that one right. Part B. Part B says, beginning with WCW, make a complete list of different possible arrangements with one correct and two wrong answers. So one correct, you could have got the first one correct and the next two wrong, or you could have gotten the second one correct and it's basically this. You can get the first one correct, or the second one correct, or the third one correct. So those are the three possible ways you can get one correct and two wrong. And then find the probability for each entry in the list. You should have missed that one, because the probabilities are all the same for all of them on that particular one, right? So, oh, sorry, my bad. Yeah, and I'm looking at it right now, and I can't see what you missed there. So, okay, so that one, part B, you should have got correct, because you just you end up multiplying 0.25 times 0.75 times 0.75, right? And then based on the preceding results, what's the probability of getting exactly one correct answer? So you should just add up those three results, right? You just add up the three results. Yeah. So, say that again. We're looking at number 3. And you got, B should have been marked correct. Now to find the answer to C, right, so basically you find that each of these three probabilities, and each of these three probabilities is that right there, 0.25 times 0.75 times 0.75, okay? And so each of those probabilities should have been 0.140625, 0.140625, 0.14. So the probability of each one of those individual things is that 0.14 number. And so part C says, well, what's the probability of getting exactly one correct? Well, you could either get it this way, or this way. And since there are three ways to get it correct, you just simply add those three together. So that's what you needed to do for part C. No, the way we got 14625 was we multiplied 0.25 times 0.75 times 0.75. So, yeah, that's correct. Add those three numbers together. Oh, and by the way, I see what you did wrong on part B. If you look closely at your number, you transposed the 0 and the 6. So, yeah. Okay. So, Unless you want to ask any more, we'll move on to question 8. All right. So question 8 is this. A Gallup poll of 1,236 adults showed that 12% of the respondents believed that it is bad luck to walk under a ladder. Consider the probability that among 30 randomly selected people from the 1,236 who were polled, there were at least 2 who have that belief. Given that the subjects surveyed were selected without replacement, the events are not independent. Can the probability be found by using the binomial probability formula? Number 8. So they're just giving us this setup of 12% of respondents believe that it's bad luck to walk under a ladder. Consider the probability that among 30 randomly selected, from there are at least 2 that have that belief. Given that the subjects surveyed were selected without replacement, the events are not independent. Can the probability be found using a binomial probability formula? And the answer is yes. You put no, because you said the selections are not independent. But the trick is this. Even though they're not independent, as long as the sample size is less than 5% of the total population size, then we don't care about independence. So the correct answer there is A. Yes, they can be treated as independent by applying the 5% guideline. In other words, the sample size that we use, the 1,236, is less than 5% of the entire population. Okay. So we can go ahead. Yeah, I mean, and now you've seen it in this practice test, I think you'll be fine on the real thing. Okay, so let's go to the next one that I see you missed, was question 10. And, okay, so this question says that in a state's pick-3 lottery game, you pay $1.46 to select a sequence of 3 numbers from 0 to 9, such as 4, 6, 6. If you select the same sequence of 3 numbers that are drawn, you win and collect $398.48. Complete parts A through E. How many different selections are possible? Well, there are 1,000, right? So this is number 8. No, sorry, this is number 10. So how many different selections are possible? Well, you can do it this way. You can say, okay, you're choosing 3 numbers, and in the first number there are 10 possibilities. For the second number there are 10 possibilities, and for the third number there are 10 possibilities. So if I multiply those 3 together, there are 1,000. You got that correct. How many different selections are possible? 1,000. There are 1,000 different selections. What's the probability of winning? Well, let's see. If you select the same sequence of 3 digits that are drawn, you win. Okay? So the probability of winning is 1 over 1,000. 1 out of 1,000. Okay, now you had that correct, but you entered 1 over 1,000. They want it as a decimal. Okay, and that's what it says. It says type an integer or a decimal. So you had that one figured out, but you entered 1 over 1,000. And I guess that's all you missed on there. So that was the only one you missed, and that's why. So just make sure you convert to a decimal. All right. I'm going to move on to the next one unless you tell me otherwise. Question 13. These following results from a test for marijuana use, which is provided by a certain drug testing company among 141 subjects with positive results. There are 30 false positives among 158. With negative results, there are 5 false negatives. Complete A through complete Z. Okay, constructed it. All right, so basically the idea is this. We had 141 that tested. So these are positive, negative, and you're going to get a true positive or a false positive, right? So in each of these categories, you're going to get true or false. Okay. So in other words, this was a positive. So the true are they actually used. No. The true is that the test is correct. The false is the test is wrong, right? And so when they say we've got 141 that got positive results, they're telling the total of this row. There's 141 in that row that had positive results, but of those, 30 were false positive. So 30 of them were false. That leaves 111 that were true. Just give me a thumbs up if that makes sense. Okay. And likewise, they give us the number of negative, which is 158. There were 5 false negatives, so that means there were 153 true. So that true tests, correct. Okay, so once you have that test, that you should be able to answer the questions. You got the total number of subjects was simply 299. That was easy, just adding up those two. Now, how many did not use marijuana? Okay. Well, which ones did not use marijuana? The true negatives and the false positives. Right? So that's 183. Is that right? And it says you answered 188. So there's our problem. So a small deal, right? So it looks to me like you're doing okay, but that's a small little deal right there. Remember, these guys did use marijuana, right? The test said they didn't, but in fact they did. These guys used marijuana. The test said they did, and they did. So that's the trick there. Question C, which says, what's the probability that a randomly selected person did not use marijuana? Well, it's simply going to be, so this is question C, did not use marijuana, 183 over 299. Convert that to a decimal. So if you miss part B, you're going to miss part C because you use 188 instead of 183. Okay? All right. I'll keep going. Next one I see is 14. Express the indicated degree of likelihood as a probability between 0 and 1. When using a computer to randomly generate the last digit of a phone number to be called for a survey, there is a 1 in 10 chance that the last digit is a 0. Your problem there, easy. You put in the fraction, it should have been a decimal. You did the right work, that's good. You need to take confidence and pat yourself on the back for that. But got to read those instructions, and they want a decimal. Okay, so that's 14. No, that was 14. Moving down to 17. Let's just take a look. So we've got this whole drive-through restaurant table, and whether the orders were accurate or not accurate. Now, it looks like we missed some problems on here. So let's look. If one order is selected at random, find the various probabilities. So the question is, the probability of getting an order from restaurant A or an order that is accurate. So let me write this down. So we're doing, this is number 17, and they're saying, what's the probability, if we choose one at random, let me just read the question. Find the probability of getting an order from restaurant A or an order that is accurate. Okay. So that's the first question. Well, so the probability of getting one from A or one that's accurate. That's what they're asking. So all we need to do is find the probability of getting one from A and add that to the probability of getting an accurate order. Okay. Now, be very careful. They don't care that they're not asking what's the probability that you get an order from A that is accurate. They're just saying what's the probability of getting an order from A. Well, there are 363 orders from A, and out of how many? Let's see. I guess we'd have to add all those up. Let me just add up all the total number of orders we have here. Maybe it's already easy. I'm not seeing it. Yes. So that's going to be on the bottom there. So the probability of getting an order from restaurant A is just the 363 over 1131. Just give me a thumbs up if that makes sense. Okay. Now that's this. Yep, that's correct. We just added up both A, because that's all we cared about. We weren't worried about accuracy. We just wanted to know what if we get one from A. So 363 over that. Now the next question is what's the probability of getting an accurate order? And so now we just need to add up all of the accurates. Notice we're not quite done. We've got to do three little probabilities here, right? Notice I've added some things in red there that I forgot. When you're doing an OR probability, you've got to do the probability of the first one plus the probability of the second one minus the probability of them both. So the probability of the first one of A is just 363 over 1131. Probability of the second one is 992 over 1131, the probability of being accurate. And then now we need to find the probability, we'll put it in red, and we're going to subtract it, of choosing of getting an accurate order from A. And that's simply 329 over 1131. So if we take all of those And the easy way to do this is to, realize, oh, these are all fractions. They already have a common denominator. So I can just, go 363 plus 992 minus 329, and then divide that answer by 1133. Yeah, so 0.907. They want, just double checking, they want 3 decimals. Yeah, 0.907. And then the question is, are the events selected of selecting an order from A and selecting an accurate order disjoint? In other words, can they happen at the same time? And they can. We can get an order that's we can select an order that's both from A and accurate. Okay. So they are disjoint because it is possible to receive an accurate order from A. Okay. And so if you change your answer to that next question to reflect that, you'll be fine. All right, last one we're looking at is number 20. And 20 says, gives us a table of this guy that's using pickup lines. If I could rearrange the alphabet, I'd put you and I together. That's sweet. The random variable X is the number of women Ted approaches before encountering one who reacts positively. So these are all this is a table of bombs to his pickup line. Determine whether the probability distribution is given. Determine whether a probability distribution is given. First of all, does the table show probability distribution? All we need to do that is to add up all of the probabilities. Okay, and we need them to add up to be 1. And if you add them up, okay, you're not going to get 1. You're going to get 0.1. So no, it's not a probability distribution. Okay. It's kind of tricky because it adds up. It looks like it's going to add up to 1, but it adds up to 0.1. Yeah, that's it, right? And then we can't do anything else because it's not a probability distribution. So you can't find the mean. You can't find the standard deviation. So there you go. We've gone through all those questions. Do which on the calculator? Yes, there is, but in reality, it's probably more work to try to figure out. I mean, unless you're a spreadsheet wizard. No, and we're not even talking about a spreadsheet. We're talking about on our calculators. Yeah, it's going to be easier just to do it, to do it by hand. So, let's see. Are you seeing me? Are you seeing my camera? Okay. So what else can we help you with? We kind of work through that practice test. I mean, that should get you ready to roll. Just remember, it looked to me like you just had some small things, right? The silly thing about putting in a fraction instead of a decimal. But I didn't see any big problems there, so you should be ready to roll for the real deal. Yeah, so if you look at the instructions, right, it tells you to round to a decimal, right? And so that's the thing you got to watch for. But yeah, I will post this. I'll get it to you some way. Right now, I know I can post it, but I don't know if I can, just post it to you. So if I post it in Canvas, okay. I mean, if you're okay with that, and if I can't find a private workaround, and I'll just do it that way. So yeah, I'll make sure you get it one way or the other. Okay. Good luck with everything. Hang in there. It'll all work out.